In today's class, we consider the codes. Remember, in our last lesson, we treated cylinders, or let's say prisms. In a cone, as we have here, a cone is from three-dimensional shape. I believe you can see this thing. It's a cone. Now, we also look at the length of a cylinder, and today we also look at the length of a cone. A cone, as you are seeing it here, this is a cone. When you open up a cone, what and what do you have? When you open up a cone, let us see the components that make up a cone. A cone has a net. And what is the net of a cone? Is what we are opening now to get. The first one we have here is the circle. And now the second one we have is this. Now, assuming that these are the things we have for a cone, what are these things? A cone is made up of a sector and what? A circle. The length of a cone is sector and circle. This is the length of a cone. A cone is made up of what? A sector. Look at a sector. And what? A circle. Now, when you want to now calculate, as we have a computing or drawn like this. This is the circle. We have the radius. This is the height, which is inside. Now the height. Now this is length of the cone, which is call it the slant length of the cone. Now, when you consider this cone now, the curved surface area of a cone, CSA, is this part, which is what? This sector, when you fold a sector. When you fold a sector, if this is what? Let's say O, or let's say this is our O, A, X, and B. When you fold this sector, A will meet B, O is now here, A will meet B here, and this X, the arc, will form the circular bottom that gave us this. Let me repeat myself. If we consider this what? Cone, the sector of a cone. That is the sector of a circle that gave us what? A cone when you fold it. If you consider this sector now as this point being A, the arc being what? X, and the point being B, the other point being B, with the center O. When you fold this, let's try folding it. Let us try folding it. You see what will happen here. When you try to fold O, A, O, B, X, when you fold this thing like this, notice that what? Notice that this your O will remain. O will remain, which is this point. A and B will join together. While X will form the circular base where we have this circle. Do you understand? If we happen to bring out this to form the curved surface, remember I told you that the curved surface is this part on top, not the circle below. So if we want to form the curved surface from here, A will meet what? B, and X will form the circular base where the O will be the apex. That's what I showed you before. Look at it now. When you meet them together, you see, AB will meet together. AB will meet. See, A and B will meet together. our X will form the circular base, where you now have this one attached to it. You see it now. You attach it to it, becomes what? A cone. So a cone is made up of a sector and what? A circle. So, and we said that when we talk about the core surface area of a cone, we mean this particular area. This particular one is what we mean by the core surface area. And now, what you need to also note is that the radius of this one sector is this length from here to here. Let us mark it now. The radius is from here to here. This is our radius. Now, do you know that when you fold this thing, this side becomes what? This one. Look at it now. When you fold this thing, remember you said this is the radius. Let us write it down. Here is the radius. Now, when you fold this radius now to this point, the radius becomes the slant length, which is 6. So when we now talk about the core surface area, we now have another radius, which is what? This base. That is the radius of this particular circle, which is from here down to this particular side. So we have two of them now. The radius of the bigger one became the length, the slant length, while we have the radius of the smaller one. Now the CSA of a cone is given as 5 arrow L. How do we generate this thing? We are going to show it to you in a moment. We said in getting the core surface area of what? A cone, that the length of arc is given as theta over 360 times 2 pi r. Remember that we are using a capital R for this one, which we told you that what? This is here is the what? The sector, and this sector is made up of 2 radii and an arc. Now, if that is the case, we also note that
none of them are even detailed.
Arc, the length of this arc talks about the bigger radius.
I don't use any hand. Sorry.
No, it talks about
You were just in my back
so
first.
this arc, the length is equal to theta over 360 times 2 pi r. And now the circumference of the base circle is this particular one, which is what? 2 pi r. Remember the arrow is smaller here. This arrow is bigger in this case. Now, we say that what? This length of arc will be equal to this one. You see it now. The length of arc, when you fold it, this arc length, you see now, the base, you see this one becomes this thing, which means that what? We are going to equate the two together, which means that what? Theta over 360 times 2 pi r is equal to 2 pi r. You see what we have now? We equated the two of them together. We notice here that what? If you take off at r and 2 pi r, which is common, that's dividing both sides by 2 pi r. What will we have? We have something like this. We have something like this. Theta over 360. Theta over 360 times r. Remember that this is not our slant length. Remember that what? R is what? L, this small L, which is now equal to what? R. So we now have that small r is now equal to theta over 360 times the length. Having noted to look into the core surface, how then do we fit in this thing? together. Now, having gotten the R to be theta over 360 times the length. Remember, the length is what? What we have as the slant height of this. The slant height of this. Now, let us go straight to the formula. Now, a CSA of a cone will now be the what? Area of what? Area of sector. Let us call it sector O, A, B, O, S, or say A, sector O, A, S, B. Let's just call it like that. Let's call it like that. Now, which is, area of a sector is given as theta over 360 times pi r squared. You see it now. Area of a sector is given as theta over 360 times pi r squared. Now, having noted that, we now have that. Remember, r is theta L over 360. Let's separate all these things. Theta over 360 r. We have that what? Pi dot r dot r. If you have this thing, you can we'll change one of these things to be what? Another. Let's continue. Do you understand what it will mean here? See, one thing you need to note. Now, the sector we are talking about is this one that has bigger R. Now, which means that we are going to change our R to this bigger R. And this bigger R is the length we are talking about. Remember, this bigger R is the length. So, from this changing to this bigger R, we have what? The length. We now have length. Length dot length. Remember, we said here, why it became so? Because we are talking about the bigger R, which is also the length. So, having noted this, that small R will have the changes to what? Bigger R. And that bigger R is our length. Now, we also have that. This comes to this point, theta over 360 L. L times what? Pi times L. Remember, this and this are the same. This and this are the same. And now remember that we have something that represents this. That thing which we have circled now has something that it is representing. And it is this thing. You see it now. So, having noted this thing now, we see that this one is something as this one we have here. We are not going to replace it, which means that this thing will now be r dot pi dot l, which is something as what? Pi r l. So, the curved surface area of a cone, the CSA of a cone, after all these things we have done, is giving us pi r l. This is the CSA of a cone. The total surface area of a cone is the area of the sector we have considered, area of one sector plus 2 circle. The CSA of a TSA of a cone is the area of a sector, which is what? The CSA and that of what? A cone. So this one is equal to pi arrow L. Why this one is equal to pi arrow squared? So what I'm talking about is pi arrow L plus pi arrow squared. Now when you have the two of them, you are going to have one gigantic formula that tells us TSA equal to pi arrow L plus pi arrow squared. When you bring pi arrow L together, remember that in factoring this thing,
Uncle,
have
have you not
something
figured this
like,
term before?
let's just write it here, pi arrow L plus pi dot arrow dot R. You see, this one is common, this one is common. So if you bring that one out, we have something like pi r bracket. What is left? L plus R. So the TSA of a cone, TSA is equal to pi r plus pi r plus pi r squared, which is same thing as pi r bracket L plus R. This is the TSA of the cone. Given these questions on the board now, this one, the slant length has been given and the radius has been given. But in this case, the slant length of this one was not given. So what you need to do is to use Pythagoras rule to find the slant length. Once you find the slant length, given the radius, you can get the total surface area of this one. But this one, everything has been given. It's just for you to start solving with the formula. I will leave you to solve this one while I work on this one. So let us start. If we have that now, we have that in the second one, we have something like this. Okay. Assuming that we now cut off one part to form a right angle triangle. This is 8 cm, here is 6 cm. We have to find this length. Now by Pythagoras rule, we have that S squared is equal to A squared plus C squared, which is 64 plus 36 in cm squared. Now, having taken note of this is 100 cm squared. Therefore, our S will now be the root of 100 cm squared to give us 10 cm. Now, the TSA will now be pi arrow bracket arrow plus L. What do we have here? 22/7, or you can leave it as pi. You can leave it as pi. Pi times arrow is 6. 6 plus 8 in cm squared. Remember, this is cm, that's give us cm squared. So, having taken note of this is pi times 6 times, this one is what? 14 cm squared. You can make your pi to be 22/7. So it takes care of this 14 to give us 2. So what we now have now will be 6 times 2 times 22. You say like 24 times 20 times 2. 24 times what? 11 to give us what? 264 cm squared. So this is the what? This is the total surface area of this shape we have here. of a cone which has a base radius of 5 cm and a height of 12 cm, and the base diameter of 16 cm and the height of 15 cm. Send in your answers once you are done. Height 4 cm and base diameter 14 cm. Say you should use pi equal to 22/7, or use what the value 22/7 for pi. In this case, the first thing you need to do is to first of all get your slant length. The first thing to do is to get the diameter from here to here is 14 cm. You can easily get the radius, and the height of this cone from here down to this point is what? 24 cm. So you can easily get your slant length using the Pythagoras rule. This is what? Here is 24, here is 7. So having seen these parameters given, we are now going to find the slant length using Pythagoras theorem. S squared is equal to 24 squared plus 7 squared. Remember, the radius is 7. So this one will give us a total of what? 625 when you compute these things. Now, S will now be the root of 625 cm squared to give us for 25 cm as our slant length. So TSA is equal to pi rho m plus pi rho squared. Or you can bring it together as we have before. Now this is 22/7 r plus 7 cm times length is 25 plus 7 in cm. So this goes with this one, 22 times 32 cm squared, because this time it is cm squared. Now this is 11 times what? 64 cm squared to give us what? 64 times what? It will give us what? 704 cm squared. This will be the total surface area of that shape. This is your assignment. Calculate the total surface area of a solid cone of base radius 6 cm and slant height 10 cm. B, base radius 8 cm and vertical height 6 cm. C, slant height 25 cm and vertical height 24 cm. You take pi to be 3.14 and approximate your answers to the nearest centimeter squared. We thank you for being part of this class. God bless you.
Okay, I've not copied anything. Please, can you wait? Sir, I've not copied anything. Please, can you wait?
Thank you.